Today we're going to do chapter 9. Section 1 is describing motion, describing speed, and then section 3 will be on acceleration and how speed, which is a component of velocity, is also a component of acceleration. We won't focus on section 2 very much. It'll be the main focus will be sections 1 and 3. So when you look at motion, what we're looking at is an object is in motion if it's moving or changing position compared to another object. Typically, you have a reference point, and that reference point is stationary. So if I'm looking on the coastline and I see boats moving, I can determine how fast a boat is moving from having a stationary object and then a distance out, and how long does it take them to travel that distance. You have to have a stationary object, that's your reference point, to be able to determine if anything is in motion. When we look at describing distance, we use the metric system, and we're primarily going to use meters, centimeters, or millimeters. You use kilometers anytime it's a longer, greater distance, and we won't be doing that in school. So you need to know your basic units for labeling. The lowercase m for meters, cm for centimeters. Remember, there's 100 centimeters in a meter, like there are 100 cents in a dollar. Millimeter is even smaller. There are 1,000 millimeters in a meter. Kilometers are larger. There's 1,000 meters in a kilometer. The first thing we have to do is calculate speed, and these are math problems. So that means I'm going to expect you to follow my directions, where you always show the formula, you always show the work, and you always show the answer with the proper units. When we're calculating speed, we're talking the distance within a unit of time. In the formula, V, that's what the letter we use to represent speed, is d divided by t. Okay, so V equals d over t. Constant speed means that the speed never changed. So it's kind of like if you're driving and you put the cruise control on. Average speed, you take the total distance divided by the total time. That means you could have periods of increased speed or decreased speed, or even a period of stopping within that total time. Okay, make sure you understand the difference between average speed and constant speed. So when we have a speed graph or a velocity graph, we're always looking at distance and time. Distance is going to go on your y-axis, that's the vertical axis. Time is on the horizontal axis, that's the x-axis. When you have a diagonal line here, we're talking equal amount of distance and time. So this would be a constant speed part. I can do average speed by taking my starting point and my ending point, and then determining that. On this other graph, I want to show you a couple other things. So here I have increasing constant speed. This horizontal line as well as this horizontal line mean I am stopped. My distance has not changed, but the time has continued on. Here you notice the slope is a little bit different, that angle, so this is an increase in speed, and then this one going down would be a negative direction, and in physics class, negative just means you change direction. So this is where you're slowing down, okay? Make sure you understand the parts of a graph. Increasing speed, constant speed, because it's the same distance over time. Horizontal line on a speed or velocity graph means you are stopped, and then a line going downward means it's negative direction, you're slowing down. Okay, so here again, to graph speed or velocity, time is on the horizontal axis, distance is on the vertical. Slope is how the steepness or slant determines how fast you're going. So when you have a constant slope, that 45-degree angle, that means you're doing constant speed, which means you're going the same distance in the same unit of time. So 1 meter per second or 2 meters per second, whatever you're doing. Okay, to calculate slope, hopefully you learned this in math class, but it's called rise over run. You choose 2 points on the line. The second point, y value, subtract the first point on the y value. That gives you your rise. Do the same thing on your x-axis. Same 2 points. You can't change your points. And then that would tell you the slope. So in my example here, I have 8 and 16 and 3 and 6 are my x and y's. So 16 minus 6, those are my y's. 8 minus 3, that's my x. 10 divided by 5 gives me 2 meters per second. All right, the section 1 review questions. So the question 1 was asking us, when do you use a reference point? And it's anytime you're comparing the motion of objects. And remember, one of them has to be stationary. Question 2, the difference between speed and velocity is that speed is just distance over time. Velocity, you have to give a direction. So remember that if you ever watch the weather on the news, they'll say the wind is in an easterly direction and they give you the miles per hour or something. That's the velocity of the wind. Question 3, they gave you some information and you had to determine that the plant grew 3.75 centimeters every hour. And then question 4, compared 2 babies and they're crawling, and baby Sarah was faster because she went 0.5 meters per second while baby Scott only traveled 0.4 meters per second.